Hello everyone, today we are going to see the kinetics, that is the part of engineering mechanics. So we know that kinetics is the branch of engineering dynamics which deals with the forces and the effect of forces on the body which is in a motion, and by considering the mass of body and the force causing the motion. Kinematics, we can say that it is the branch of engineering mechanics It is divided into two parts. It is statics and dynamics. So statics is what? It is the branch of engineering mechanics which deals with the forces and effect of forces on the body which is in a rest. So body is in the rest. So we can second dynamics. So it is the branch of engineering mechanics which deals with the forces and the effect of forces on the body when the body is in motion. Dynamics is divided into two parts. One is kinematics and second is kinetics. So kinematics, we can define kinematics, it is the branch of dynamics which deals with the forces and effect of forces when the body is in motion, but only considering the mass of the body. So here the only mass of the body is considered, the force causing motion is not considered. Second part of the dynamics, that is the kinetics. So kinetics, it is the branch of dynamics which deals with the forces and the effect of forces acting on the body when the body is in motion, and with considering the mass of body and the cause of motion of the body. Today in this lecture we are going to see what is ALEMBERT principle. Now we are going to see what is equilibrium, then we will see what is dynamic equilibrium, so that we can understand what is ALEMBERT principle. So let us see what is equilibrium. Suppose this is the body and the number of forces acting on the body. So let's say this is the P force, that is the pull force, and this is the frictional force F. This is the weight of the body, or we can say the self-weight of the body, and this is the normal reaction. Then we can say that if the body is in equilibrium, then the summation of horizontal forces must be equals to 0. The summation of vertical forces must be equals to 0. Summation of horizontal forces, that is summation Fx, must be equals to 0, and summation of vertical forces, that is summation of Fy, must be equals to 0. Then one another condition is there, that is the summation of movement of all the forces about any point must be equals to 0. So now we will go for the dynamic equilibrium. So dynamic equilibrium are the equilibrium which are applicable on the body which is in the motion. So that is nothing but the kinetics part. So if we consider the body, this body is in motion. So this body is in motion, and the force causing the motion is F. So this is nothing but the external force, and due to this external force acting on this body which is in motion, this body tries to resist, that is nothing but the inertia force, and that is nothing but the MA. So MA is nothing but the inertia force. So here in this case, the summation of horizontal forces, that is the external forces acting on the body, is only force, that is the pull force. So here F is not equals to MA. So therefore resultant is not equals to 0. Hence we can say that the body is in dynamic equilibrium. The resultant of the external forces is not equals to 0, then we can say that the body is in dynamic equilibrium. So ALEMBERT principle said that the algebraic sum of external forces, that is summation of F, must be equals to the inertia force, or in other words we can say that the algebraic sum of external forces, that is summation F, and the inertia force, that is minus of MA, is equals to 0. So we can say that summation F plus of minus ma is equals to 0. So this is nothing but the mathematical expression for the D'Alembert principle. For particle which is in rectilinear motion, summation of fx plus minus of max is equals to 0 and summation of fy plus minus of may is equals to 0, where ax is the acceleration in x direction and ay is the acceleration in y direction. So this is for the rectilinear motion. Then if the particle is moving in a curvilinear motion, summation of ft plus minus of ma in acceleration in transverse direction or the acceleration along the direction of the tangent must be equals to 0 and summation of fn plus minus man must be equals to 0, where fn is the normal force and an is the acceleration which is normal to the curvilinear motion of the particle. Suppose this is the path traveled by the particle, this is the particle and this is the path traveled by the particle. This is the normal of this curvilinear motion and this is the tangent of the curvilinear motion. In next video we are going to see some numericals based on the D'Alembert principle.